Good morning, students. Chapter 3 continue motion in a straight line. Yes, we have discussed about equations of uniformly accelerated motion, its use. Now, there is another case of uniform accelerated motion. See, if you observe this, if I drop this chalk, yes, it is moving in vertically downward direction in a straight line. If effect of air resistance is neglected. You know, from surface of earth, if we release any object, that object is moving in vertically downward direction due to influence of gravity of earth. And if we neglect resistance of air, okay, its medium, then it is called free fall. Remember, if we drop, not throw, if we release or if we drop any object, it is moving in vertically downward direction due to gravitational force. Yes, due to gravitational force, gravitational acceleration is produced, and that gravitational acceleration is denoted by G, 9.8 meter per second square. On surface of earth and about some height, okay, up to some height, we can consider this value of gravitational acceleration constant. Okay, so if I am on surface of earth, means on ground, if I am on a top of building, then yes, I can consider gravitational acceleration constant, because up to some height its value is nearly same, that is 9.8 meter per second square. So if I drop this chalk from this height, okay, from top of building, okay, then acceleration of this chalk will be same. So we can say this free fall is case of uniform accelerated motion. Yes, see, free fall, motion of object under free fall. An object released near the surface of earth is accelerated downward under the influence of force of gravity. If air resistance is neglected, object is said to be in free fall. Okay, the magnitude of gravitational acceleration G is equal to 9.8 meter per second square, and on a surface and up to some height we will consider it as constant. Hello students, if I drop chalk from this point, at this point gravitational acceleration is 9.8. At this point 9.8, at this point 9.8, at each and every point its gravitational acceleration is 9.8 constant, and that's why free fall in case of uniform accelerated motion. Free fall is case of uniform accelerated motion. Clear? Okay. Now, due to gravity, object is moving vertically downward. But if I throw object in vertically upward direction against gravity, yes, we have to study such cases. Then in gravitational field we will have two cases. One in vertically upward direction and one vertically downward direction. So there are two directions. So for this we are taking positive y-axis, means upward direction as positive, negative y-axis means downward direction as negative. It is sign convention. Yes, it is important in this case. What is the sign convention? Okay, we will consider upward direction as positive and downward direction as negative. Now, how to use this sign convention? We will see in sums. Don't worry. Okay, now see, acceleration due to gravity is always downward. So A is equal to minus G. Why minus G? Because object is falling freely in downward direction. And see, upward direction is considered positive while downward direction is considered negative. That's why here A is equal to minus G. What is meaning of minus? Object is moving downward. What is meaning of minus? Object is moving in downward. Acceleration is in downward direction. Clear? What is meaning of minus? Okay. Object is released from rest. I said object is released from rest. So its initial velocity v0 is equal to 0. So now you already know kinematic equations for uniformly accelerated motion. First equation, v is equal to v0 plus at. V is equal to, what is v0 initial velocity? 0. A is replaced by minus gt. Clear? What is value of g? 9.8, so it is minus 9.8 meter per second. Clear? Okay. Second equation, x is equal to v0 t plus half at square. But here I have replaced x by y, because here we have to deal with vertical plane. Okay. So y is equal to, again, v0 t0 minus half gt square. Okay now? You have equation x is equal to v0 t plus half at square. But initial velocity is 0, and you have to replace a by minus t. Okay, so you will get g by 2, 9.8 divided by 2 minus 4.9 t square. Okay, now last equation, v square minus v0 square is equal to 2ax. V square minus v0 initial velocity 0 is equal to 2. A is replaced by minus g, y. So 9.8 into 2, it is 19.6 y meter square second square. Clear? Okay, so it is about free fall. In free fall, you have to make these changes. Okay, now graph for free fall. What is graph of acceleration, velocity, and displacement with respect to time? First graph, acceleration versus time. Now you may ask me a question, sir, why you have drawn this line? Okay, in general graph we are taking axis like this, but now in this case, see, here object is falling in downward direction. So what is value of acceleration? It is C minus. So I am taking acceleration in negative direction. While time axis is always positive. Okay, acceleration is constant, that is minus 9.8. It is 0, minus 1, minus 2, minus 3, minus 4, minus 5, dash, it is minus 9.8. At time t is equal to 0, acceleration minus 9.8. At time t is equal to 1, at time t is equal to 2, 3, 4, 5, etc. See, at this point acceleration is 9.8. Okay. So it is graph of acceleration versus time for free fall. Now for velocity versus time. See, it is velocity versus time graph. Again, object is moving in downward direction. So if with the help of this equation you find velocity at each and every time, v is equal to minus 9.8. Put value of t 1, 2, 3, 4, 5. You will get minus values. Yes, you will get minus values. Okay. So that's why we are taking this velocity axis in downward direction. Okay. And yes, with respect to time, why it is a straight line? Because in equal time interval, change in velocity is equal. And due to that, this acceleration is constant. And don't worry, in the next topic, in the next lecture, I will do this. In equal time interval, change in velocity is same. Third one is y versus t, displacement versus time graph. And this displacement versus time graph is not a straight line, but it is a curve like this. Because in this case, in equal time interval, distances traveled are not same. In equal time interval, distances traveled are not same. Again, these two things we will prove next. Okay, so it is all about free fall. What is free fall? Now one question related to gravitational acceleration. See what is question. Object is thrown vertically upward with velocity v0. Find maximum height and time to reach maximum height. Now see what is question. If you throw any object, for example I throw this chalk. okay, with some velocity, initial velocity. Okay, to throw in upward direction, we have to give some velocity. Okay, okay then. I have this chalk here. Yes, this chalk is moving in upward direction. It is moving in upward direction. It is moving in upward direction. No, by itself, it cannot move in upward direction. We have to throw it. We have to throw it in upward direction. So let object is thrown vertically upward with velocity v0. Find maximum height and time to reach maximum height. Okay. Now see, if you observe, if you throw any object in upward direction, gravitational force is acting in downward direction. So as object is moving in upward direction, its velocity, its speed decreases. Its velocity or its speed decreases. When it is at maximum height, its velocity becomes zero. Why? Because object is moving in upward direction, but gravitational force pulls the object in downward direction. So as it is moving in upward direction, its velocity decreases, and at maximum height its velocity becomes zero. Clear? Okay. Gravitational acceleration G. It is in downward direction. So first question, how to solve? See, okay, time to reach maximum height. I will use this equation. V is equal to V0 plus A. Now what you have to change? See, what is final velocity at maximum height? 0. Initial velocity V0 in upward direction, so it is positive. A, it is minus G. Okay, and T is replaced by Tm, time to reach maximum height. So Gtm is equal to V0. So Tm is equal to V0 upon G. Okay, if you find any object with velocity V0 in upward direction, then time to reach maximum height is V0 upon G. Clear? Any doubt? Okay, again, what you have to remember, if you throw any object in upward direction, gravitational pull is always in downward direction. Its velocity decreases. At maximum height, its velocity becomes 0. And then after, due to gravitational force, it again comes to ground. Now second question, what is maximum height? See, how to find maximum height? Y is equal to V0t plus half at square. How to simplify this? See, maximum height is denoted by h. V0, it is V0. Maximum height is achieved when time is equal to time to reach maximum height. So here I have to replace T by Tm minus half G Tm square. So h is equal to V0. What is value of Tm? V0 by G minus half G. What is value of Tm? It is V0 square upon G square. 1G cut. Okay. So h is equal to V0 square upon G minus half V0 square upon G. So h is equal to V0 square upon 2G. H is equal to V0 square upon 2G. Clear? So you have to remember this question. Okay. Now these two are results. What is time to reach maximum height? V0 upon G. What is maximum height? V0 square upon 2G. If I ask you one question, I throw this chalk with initial velocity 40 meter per second. I throw this chalk in upward direction with 40 meter per second. Then what is time to reach maximum height? And what is maximum height? Drop your answer in comment box. Pause your video. Write down from board. Next lecture. Okay, now one theorem, Galileo's law of odd numbers. What is statement? The distance is traversed during equal intervals of time by a body falling from rest, means uniform accelerated motion, stands one another in the same ratio as the odd numbers 1:3:5:7. Now what is meaning of this? See, we are taking one example. It is a building. Suppose object is initially here, means on top, that it is named y0 at origin. So initial position y0 is equal to 0. Initial position y0 is equal to 0. Now what is equation of displacement, distance? Y is equal to minus half gt square in case of free fall. In case of free fall, falling from rest, y is equal to minus half gt square. Now we will find what is position of object after each and every second. For example, see here, at time t is equal to 0, what is its position? y0 is equal to 0. At time t is equal to 1 second, y1 is equal to, in this equation you have to put t is equal to 1. So minus half g1 square. 1 square it is 1, so it is minus g by 1. Clear? Okay? Okay. Now, for example, here it is. It is y1. Okay. Now, at time t is equal to 2, what is distance traveled? y2. y2 is equal to minus half g2 square is equal to minus g by 2. 2 square means 4, means it is 4y1. How 4y1? See, y1 is equal to minus g by 2. So minus g by 2, minus g by 2. Instead of this minus g by 2, I can write y2. So minus g by 2, y1, 4y1. Clear? So what is distance traveled in, what is position at time t? It is y. Any doubt? Any doubt? Okay. At time t is equal to 3, y3 is equal to minus half g3 square, minus g by 2, 3 square 9, minus g by 2 again, it is y1, so it is 9y1. Clear? Okay. At time t is equal to 4, y4 is equal to minus half g4 square is equal to minus g by 2, 16, so it is 16y1. Now you know what is at time t is equal to 5, 25y1. At time t is equal to 6, 36y1. At time t is equal to 7, 49y1. Yes or no? Hello, you understand? Okay, so at time t is equal to 1 second, its distance traveled is y1. At time t is equal to 2 second, distance traveled is 4y1. At time t is equal to 3 second, distance traveled is 9y1. At 4, 16y1. At 5, 25y1. Yes or no? Yes. Now, if I say what is distance traveled from t is equal to 0 to t is equal to 1 second. What is distance traveled from time t is equal to 0 to 1 second? See here. At time t is equal to 0, what is position? 0 means here. At time t is equal to 1, its position is here. So what is distance traveled? Yes, it is y1. Hello? Yes, it is y1. So here it is. y1 minus 0 is equal to y1. Clear? Okay. Now here, distance traveled from time t is equal to 1 to t is equal to 2 seconds. See here. In time t is equal to 2, it is position. At time t is equal to 1, it is position. So if you want to find what is distance between 1 and 2 seconds, means this distance. Okay. And how to find this distance? Yes, it is y2 minus y1. y2 minus y1. What is y2? 4y1. And it is y1. So it is 3y1. Clear? What is distance traveled from t is equal to 1 to t is equal to 2 seconds? 4y1 minus y1 is equal to 3y1. Similarly, what is distance traveled from time t is equal to 2 to time t is equal to 3? See, at time t is equal to 2, y2 is equal to 4y1. At time t is equal to 3, y3 is equal to 9y1. What is difference of these two? y1. What is distance traveled from time t is equal to 3 to time t is equal to 4? At 3, 9y1. At 4, 16y1. What is difference between them? It is 7. Clear? So you understand this. if I am taking successive time interval 0 to 1 second, distance travel is y1, 1 to 2 second, 3y1, 2 to 3 second, 5y1, 3 to 4 second, 7y1. Clear? So if you take successive 1 second, 1 second, 1 second, 1 second, what is ratio of distance travel? y1, 3y1, 5y1, 7y1. And if you take the ratio, it is 1 is to 3 is to 5 is to 7. Clear? So it is about distance. See, and that's why y versus t graph is not a straight line, but it is a curve. Now what about velocity? See here, what about velocity? What is equation of velocity? V is equal to minus gt. At time t is equal to 1, what is velocity? V1 is equal to minus g. Yes, at time t is equal to 2, V2 is equal to minus g into 2, minus 2g means 2v1. At time t is equal to 3, minus g3, minus 3g is equal to 3v1, v4, 4v1, v5, 5v1. So see. Between any time interval, what is change in velocity? V1. What is change in velocity? V1. Here it is V1, then 2v1, 3v1, 4v1, 5v1. If you take change in velocity for any time interval, 3v1 minus 2v1, 1. 4v1 minus 3v1, 1. 5v1 minus 4v1, it is v1. Yes or no? Yes, it is v1. So here, in equal time interval, change in velocity is same, and that's why its graph is a straight line. Clear? So it is Galileo's law of odd numbers. How to prove this? Clear? You have to just remember equations. Okay. Now I have one question. For example, distance travel in first second is 10 meter. So what is distance travel in next 1 second? What is distance travel in next 1 second? It is as your homework. Drop your answer in comment box. Okay, pause your video and write down from what.